Time for us to switch gears here a bit and move over to the ASA. And what we're configuring now with the ASA via the ASDM is a firewall as opposed to the Cisco iOS-based firewalling we were doing before on an actual Cisco router. And we use Cisco Configuration Professional there. It's a good GUI to be familiar with. That is actually going to be phased out over the next year or so, this being October 2017 when I'm recording this. But it's still going to be out there in production networks, may well pop up on your CCNA security exam. So it's a good little GUI to be familiar with. And the reason I'm bringing all that up right now is whether it's the CCP, whether it's the ASDM, when you're working with these Cisco GUIs, if you're on an exam, job interview, even real-world networking, if you're asked to do something or you need to do something that you've never seen before, you've never done before, just stay calm, start clicking around because every bit of information you need is right in front of you. And I think you'll find these Cisco GUIs to be very intuitive. Now, I'm going to save you some major headaches when it comes to working with the ASA because I'm about to hit you over the head with several very important fundamentals. I'm going to mention them on the board. We're going to do a walkthrough and make sure we have these rules down cold because it will make life a lot easier on you. It will help you eliminate some unnecessary troubleshooting. And now you're going to see exactly what I'm talking about with these numeric security levels. And you'll notice I have the word usually in paren 3 times, which is a record for me. And there's a reason, but with the numeric security levels, 0 to 100, we configure them, we can set them to whatever we like, but usually you're going to put 100 on the interface connected to the most trusted network. And what network is that going to be? Of course, silly question, right? That's the network that you and I are actually admining, right? We're the network admin of the inside network, and that is usually where you're going to put 100 on the interface that is connected to our most trusted network. Usually, you're going to put 0 on the least trusted network, which is going to be that outside world, right? We don't trust that at all, which is one reason we have a firewall. And we will assign a number in between those to the DMZ. Now, the reason I say usually so often here, especially with emphasis on the first two, is that you are not locked in to assigning 100 to the inside interface and 0 to the outside interface. You see those values so often that you think they're a requirement. And it throws you a little bit, whether it's a practice exam question, job interview, real exam, what have you, when all of a sudden you see different security levels and you're like, what's going on here? Well, as long as your inside interface has a higher security level than your outside interface, then you're good. And your DMZ value just needs to be a number in between the two. So again, usually you're going to put 100 on your inside interface and 0 on your outside interface, but just to hit you over the head with it one more time, that is not a requirement. Now, I've removed all the hardware from our inside and outside areas in our DMZ. And just a reminder, these are not zones. Well, we're not dealing with zone-based firewalling any longer. We're working with a pure firewall with the ASA. And we've got our inside interface, we've set that to 100, our outside interface security level of 0, DMZ interface security level of 40, could have been 50, could have been 99, anything between 0 and 100, but just watch that if you're using the non-100 and 0 values on your inside and outside interface. You want your DMZ interface security level to be higher than that of the outside interface, but lower than that of the inside interface if you want your inside host to be able to initiate communications with your DMZ devices. Whew. A lot going on there, I know, but that's why we have all these walkthroughs coming up, and that's also why I took all the hardware off, because it makes those easier to keep up with. We're going to hit those walkthroughs in just a moment. By default, here's the major rule: traffic sourced from a higher rated interface that is destined for a host off a lower rated interface will go through. And I know you suspected that even if you didn't know it just by looking at that last drawing. But again, traffic will flow from a higher interface to a lower interface. It's just that simple. So with that rule, that means our inside host should be able to initiate communications with our outside host, and outside hosts will be able to respond because of that state table entry. Now, a quick note here out of nowhere, because I know you were thinking this, especially if it's the first time you've seen the security levels. It's like, okay, what if there's a tie? And that was my first thought when I saw them. You hear the higher to lower interface traffic flow. It's like, what if they're a tie? Well, you might think it would go through on a tie, but it will not. Packets cannot flow successfully from one interface to another if the interfaces have the same security level. So a tie there is just like a loss. Now, this is configurable. We can change it, and I'll show you the command at the command line as well, and I'll also show you how to do that in the ASDM in the very next video. But it's an important default to keep in mind that by default, same security level is a no-no if you want traffic to go between those interfaces. And as you would expect, and this is one reason we have the firewall, outside hosts will not be able to initiate communications with inside hosts or hosts in the DMZ. Makes perfect sense, right? That's why we have a firewall in the first place. But let's do some walkthroughs here, and I'm going to bring that down just a little bit. I want to make this as large as I could for you. And again, just using the boxes to represent our inside network, outside network, and our DMZ. These are not zones. But if we have the interface levels that we've talked about so far, 100, 0, and 40, if traffic is being initiated behind the inside interface and it's destined for a host behind the outside interface, that's going to go through, because it's going to go through to begin with because you're flowing higher to lower, and then the return traffic goes through because of that state table entry. When the firewall gets it, when the ASA gets it back, it's like, okay, let me look that up. Okay, it's part of an existing conversation. I will let it through. No problem there. Now, what about the inside interface to the DMZ? That's no problem here because, again, the security level, the initial traffic is flowing from a higher rated interface to a lower rated interface. So the traffic goes through, and then the return traffic goes through again because of the state table entry. So far, all of our traffic is flowing pretty well through this firewall, pretty freely. But the thing is, we've only looked at traffic behind the starting or initiating behind the inside interface. When it initiates from behind the outside interface, ain't nothing going through, right? Because no traffic initiated by outside hosts are going to go through because the inside and DMZ interfaces have higher security levels. Now, this is a good default, right? I mean, this is why we have a firewall in the first place, is to protect our inside devices, our inside network, and should we have one, a DMZ, from all these outside hosts. But the thing is, we can't just lock the door, slam the door and lock it and not let anybody through, because what devices do we typically have in our DMZ? We got e-commerce servers, we got email servers, we got web servers, we got FTP servers, we got all kinds of things that sure the host behind the inside interface will be communicating with, but we probably have some outside hosts that need to get to our e-commerce servers. So that's where in the ASDM we're going to create firewall rules. It's really just an ACL saying, okay, if traffic is sourced from here and destined for here, then go ahead and let it through. And of course we'll have a port number on there as well, because we want to restrict traffic as tightly as possible going from the outside interface to the DMZ. Getting a little ahead of myself there, I admit, but I just want to throw that in now, because by default, the outside host can't talk to anybody, and that's probably a little too restrictive for our network. Now, what about traffic initiated in the DMZ? Because that's going to happen. Web servers, e-commerce servers, or FTP servers, usually they're being talked to. Someone else is initiating the conversation, but there will be times when those servers need to initiate conversations of their own. So if they need to do so with a host behind the outside interface, that's no problem, because traffic initiated in the DMZ and destined for a host on the outside network can go through, and again, outside hosts would be able to reply because of our state table. What about the DMZ to the inside interface? Can devices in the DMZ initiate conversations successfully with devices behind our inside interface? No, they can't. They're out of luck because the security level, we would be flowing from lower to higher, and we know that it doesn't work that way. Again, traffic always needs to flow when it comes to these security levels. It needs to go downstream, if you will. It needs to go from a higher level to a lower level. Whew, a lot of walkthrough there, a lot of information, but a couple of simple rules. And knowing these simple rules will save you a lot of time and headaches on your CCNA security exam and in real-world networking as well. So when you come back, we're going to hop over to the ASDM. We're going to take a look at that. I'm going to show you how to ping from the ASDM and maybe a couple of other little features as well. That's all coming up next. See you there.